What's up, bestie?
Wait a minute. Who are
The
you?
unit circle is what made me have to drop out of the smart kid math class into the dumb kid math class because I kept failing everything. I literally failed all of the quizzes about the unit circle.
Bruh.
And I had to remove myself from the class. So this is gonna be a little bit therapeutic for me. But the unit circle isn't hard. It just looks so confusing and scary. But I'm gonna explain everything to you in normal people terms. So let's begin this therapy session. This is a graph. We should be familiar with this graph. Fingers crossed. This is the point 1, 0. This is the point 1, 2. This is -1, 1, right? Okay, I hope we're feeling good about that. The unit circle is when you draw a circle on this graph and it touches these 4 points. All right, thanks for watching, everybody. No, that's literally what the unit circle is. These are some points on the unit circle. And then there's also all of these points that are along the unit circle but aren't necessarily on a whole number. So if we take a closer look here, these are also all the points on the unit circle. And now it's starting to look a little bit scary, but don't worry.
Hey babes, don't worry about this. We have another video on how to memorize the unit circle. The link is in the bio, of course.
You also need to know about sine and cosine. What are sine and cosine? Well, you probably recognize sine and cosine from trigonometry with the triangles and that bullshit, but sine and cosine are functions of the unit circle. Stay with me, I'm going to explain that. So you're going to get a point on the unit circle, and your teacher's going to ask you what's the sine and cosine of this point. Whatever is in this slot right here is cosine, and whatever is in this slot right here is sine. I'm not tricking you. It's literally that easy. So they give you a point on the unit circle. This is cosine and this is sine. All right, let's try this one. Cosine is again whatever's in this slot, which is 1, and sine is whatever's in this slot, which is 0. It's literally this easy. I'm not tricking you. All right, try this one. Again, whatever's in here is cosine, and whatever's in here is sine. The next thing that you need to know is this thing called radians, and it's basically instructions on how to get to a certain point on the unit circle. So imagine you're standing right here, okay? You're always going to start right here on the unit circle, and you want to go on a walk around the circle. So you start walking, you're always going to go this way, and you're going to end up right back where you started. So it takes time to walk around this circle. So say, you're at 1 second, 2 seconds, 3 seconds, so forth. This is measured in something called radians. So if you start here and you walk halfway around the circle, you're going to end up at this spot. This distance that you just traveled here is called pi. So to get all the way around the circle, that's 2 pi. All right, so if you walk halfway around the circle, that's pi. What if you walk half of that? So what if you ended up right here? Well, if this is pi and you walked half of that, this length here is just going to be 1/2 of pi, so pi over 2. All right, so this is the unit circle that you're probably familiar with from class. And see what I'm talking about? Here's pi over 2, and then you have all of these different little values for different numbers of pi. If your teacher's like, okay, what point is 7 pi over 6 at? You have to walk along and check for 7 pi over 6 until you get to 7 pi over 6 right here. Whatever point is at 7 pi over 6 is the corresponding point that 7 pi over 6 belongs to. Why should you even care about this? Well, sines and cosines are going to look like this. It is called the cosine of pi. This is just telling you, okay, take the cosine of the point that's correlated when you walk pi radians along the unit circle. So for this example, remember, we always start right here and we walk until we get to pi. Well, here's pi, And so we have to look at this point that's right by pi. So we have to look at -1, 0, and then evaluate for cosine and sine. Well, cosine is this one right here, right? And sine is whatever number is in this value. So the cosine of pi should be -1, and the sine of pi should be 0. All right, let's look at this one. It's telling us to evaluate the sine and cosine at pi over 2. So we start here and we walk along the unit circle until we get to pi over 2, and we look at that point. That point's 0, 1. All right, well, it looks like cosine is going to be 0 and sine is going to be 1. I cannot, this literally made me fail out of this class. Let's try this example. All right, pi over 4. We start here and we walk until we get to pi over 4. Well, that's this point right here. So cosine is going to be √2/2, and so is sine. Something that's important to mention is sometimes you might see cosine of a negative number. So let's say your teacher gave you cosine of -pi over 2. This negative just means walk the same distance, except instead of walking this way, you're going to walk in the opposite direction. So in this case, -pi over 2. Well, here's pi over 2. So it's going to be this amount of distance, except in the opposite way. So it's going to be in this way, and we would land at this point. So even though this is not pi over 2, -pi over 2 is going to bring us to this point right here. And if we look at this value, it's asking for the cosine of this point, which is equal to 0. Another thing that you need to know is sometimes you'll see this in degrees. See these little degrees that like correspond with each pi value? It's just a different way of measuring the same thing that we're talking about, but one's called radians with pi and the other is called degrees. So in this case, so remember we start here and then we walk until we hit 30 degrees, which is here, and evaluate sine and cosine at this point right here. So cosine would be, oh wait, the answer's right there. Fuck, okay. Well, oops, okay, that was a freebie for you guys.
You win.
So again, if you start here and you go all the way around the unit circle, that takes 2 pi radians and 360 degrees. These two are equal to each other.
Okay, besties. So your calculator is going to have cosine and sine in a degree setting and a radian setting. So you want to make sure if you're taking the cosine of something in degrees, you want to adjust your calculator accordingly. Make sure you pay attention to those settings. Okay? Okay?
And with a circle, when you walk all the way around a circle, you're going to end where you start from. So yeah, this is 2 pi, but it could also be measured as 0 because that's the starting position. The last thing you need to know is the tan function. Tan just means, so if it asks you to take the tan at a certain point, you just have to take the sine value, plug it in to the numerator, and then divide it by the cosine value. So yeah, I hope this introduction to the unit circle kind of cleared some things up. I thought the unit circle was like impossible to learn. It was so confusing. And it literally made me drop out of like this math class, and I thought because I couldn't get the unit circle I was bad at math, and now I have a degree in mathematics. If you're not getting the unit circle right away, that does not mean you're bad at math at all. It's just kind of like a super foreign concept, and that's okay. Okay, you don't need to know this part for your tests or quizzes, but this unit circle is really fucking cool. If you graph cosine, it looks like this, and if you graph sine, it looks like this. And these patterns occur everywhere in nature. You can see it in a pattern of someone's breath. You can see it in waves. You can see it in the tides of the ocean. You can see it in moon cycles. You can see it in year-round temperature cycles. And nobody knows why. None of my math teachers ever talked about it. Probably because nobody knows why. You see it in like music vibration. You see it everywhere. And yeah, I would be down to make a whole video about this, but it's something kind of cool where you see math like every day in real life.